5.3 Properties of Integrals. So in the previous sections we've talked about how to turn Riemann sums into integrals to make our lives a little bit easier and actually determine the exact area under a curve. Today we're going to talk about how we're going to use properties of integrals in order to solve these kind of problems. So for this video I'm going to scroll through some of the rules for definite integrals. First rule: if you have an integral from a to b that is equal to the negative of that integral from b to a. So what I mean by that is that if you have an integral from a to b that is the same as finding the integral from b to a and then multiplying that by a negative. That sometimes comes in handy if you want to integrate from a smaller value to a larger value, or vice versa, larger value to a smaller value. The next property is if you integrate from one point to the same point, the area is always 0. So again, if you integrate from say 5 to 5, the area is 0 because you don't have any width. You don't have any distance that you're integrating over. The next property is that the integral of a constant times a function is equal to the constant times the integral of a function. This is called the constant multiple rule. The way this works is essentially if you have the integral from 0 to 1 of 5x, that's equal to 5 times the integral from 0 to 1 of x. The fourth rule: if you have the integral of a sum that is equal to the sum of the integrals. So you can break up integrals with an addition or subtraction sign by finding two integrals separately. The next rule, which we've already kind of used, is if you integrate from a to b plus the integral of b to c, then it's the integral from a to c. So if these values are the same, you can both separate them or put them together as one integral. All of these properties will work vice versa because of the equal sign. This one's kind of weird. The max or min equality. This is saying that the minimum of f, so the minimum value of f times b minus a is less than or equal to the actual integral, which is less than or equal to the maximum value times b minus a. This would be, if it was an increasing function, the left Riemann sum, and this one would be the right ram. So the actual integral is somewhere in between the left ram and the right ram, which is something we have noticed. And the seventh property: if f of x is greater than or equal to g of x on an interval, then the integral of f of x is greater than or equal to the integral of g of x. If f of x is greater than or equal to 0, then the integral also has to be greater than or equal to 0. These are some properties that we're going to use to solve integral problems in later examples.